Hello everyone and welcome back to my online teaching platform. Still on application of differentiation. We have our 13th question here and we have to find a solution to it. Alright. So the first part of the question 13 says that given the implicit function, we have to find dy dx at a point with x coordinate of -3 and y coordinate of 0. Alright. And the b part also has an implicit function where b is a constant. Find dy dx at a given point with x coordinate of 0 and y coordinate of 1. Alright, so let us start with. So when you know how to find dy dx, it means we are going to differentiate the function y with respect to x. So our 13a, let us answer question 13a first. Alright, so this is the function x cubed multiplying y minus 4x plus 3y equal to 2. Okay, so we need to differentiate this particular function. You could see that the first term is x cubed times y, which is product of x cubed and y. So we can apply the product rule over here. So we differentiate the x, then we get 3x squared, then it's going to multiply the y. Then you now add it to, you now maintain the x cubed, and you differentiate the y, which will give you 1. Okay, so times 1. Then because y is a dependent variable, is going to get a result of 1 times dy dx. All right, you multiply whatever you are getting by dy dx. Then we have here to be, we differentiate for -4x, we are going to get -4. Now when you differentiate the 3y, you are going to get the result to be 3, but the result will be multiplied by dy dx, which is the same as the y prime. Okay, all equal to 0. When you differentiate 2, the constant term, we get a result of 0. All right, so let us continue with this. We have 3x squared y, then plus x cubed dy dx, and minus 4 multiplying 3, sorry, minus 4 plus 3 dy dx, all equal to 0. So you need to group like terms. So we have to bring all the terms with dy dx to one side. So we have here to be x cubed dy dx, then plus, we have plus 3 dy dx. Okay, then all equal to, we transpose this term to the right hand side and also transpose the -4. So we are going to get 4 minus 3x squared y. All right, so we can now factorize this. We have these two terms have a common factor, which is dy dx. So we can factorize dy dx out. So we are going to get x cubed plus 3 in bracket multiplying dy dx. All right, then equal to 4 minus 3x squared y. So this is what we are getting. So what we do, we divide through by the coefficient of dy dx, because we have to find dy dx. So we have x cubed plus 3 in bracket dy dx, then equal to 4 minus 3x squared y. So we now divide through by x cubed plus 3, then here to be x cubed plus 1 3. So we have a result of dy dx being equal to 4 minus 3x squared y, then divided by x cubed plus 3, right? And we have to find dy dx at a given point. So at the point with x coordinate of -3 and y coordinate of 0. So we just need to substitute this component into the dy dx. So we have our dy dx being equal to 4 minus 3 x squared. So the x value is -3, so it's going to be -3 squared, multiplying the y value, which is 0, right? Then divided by our -3 exponent 3, x cubed plus 3. Okay, so we'll be getting 4 minus 0 because everything here will give us 0 because we are going to multiply it by 0, so that part becomes 0. So we have 4 minus 0, then we have our denominator to be 3 times 3 will give us negative 3 times negative 3 will give us positive 9 times negative 3 will give us negative 27 plus 3. All right, so we are going to get the result of 4 divided by negative 24, and this is the same as negative 4 divided by 24, and we can simplify this. Okay, 4 into itself we have 1, 4 into 24 we are going to get 6, so we are going to get a result of negative 1 divided by what? 6. So this is the value of dy dx at the point with x coordinate of negative 3 and y coordinate of 0. All right, let us now look at the b part of the question, which says that, so we have the b part, which is if half of x squared plus y squared equal to bxy, okay, where b is a constant, we are to find dy dx at, so we are to find dy dx at a point with x coordinate of 0 and y coordinate of what? 1. All right. So it means we need to differentiate the implicit function. So let's look at it. We have half here, okay, then x squared plus y squared equal to 6x, sorry, not 6, is bxy. So you can multiply through by the LCM. You can multiply each of them by 2, this side by 2, so 2 times half of x squared plus y squared, and here 2 times 2. So we are going to get x squared plus y squared to be equal to 2bxy, right? 2bxy. So what do we do now? What are we supposed to do? Differentiate each of the terms with respect to x. So here will be 2x, all right, plus here will be 2y, and the result will multiply by dy dx, all right, equal to, here we have b, 2b to be a constant, so you can bring 2b out. Then you apply the product rule on x multiplying y. So when you differentiate x, you get 1. So 1 times that's dot y. Then plus you maintain the x and you differentiate the y, which will give us 1. So because it's a dependent variable, we are going to get it as 1 dy dx. So dot 1 dy dx. All right. So we have here to be 2x plus 2y dy dx equal to, so we have our 2b out because this is the constant, so factorize it out. Let's work on a bracket. We have y here, then plus x dy dx. All right, nicely. Continue. We are going to get 2x plus 2y dy dx equal to 2by plus 2bx dy dx. All right, so we group like terms. So we are going to get 2y dy dx minus 2bx dy dx. All right, so we have transposed this one to the left hand side. It becomes negative, then equal to 2by. Then I will now transpose this one also to the left hand side. It becomes negative, so 2x. Okay, so we can now factorize dy dx out. So we have 2y minus 2bx in bracket. Then here we have dy dx equal to 2by minus 2x. What do? We divide through by the coefficient of dy dx. So it's going to be 2y minus 2bx dy dx in bracket like this equal to 2by minus 2x. We divide through by 2y minus 2bx. Here to the same 2y minus 2bx. Right? So this cancel this. We have dy dx equal to 2by minus 2x divided by 2y minus 2bx. Right? We can factorize 2. It's clear the numerator, the fraction has common highest common factor. So the numerator is, you can factorize 2 out. So we have by minus x. Then the denominator too, we can have 2 multiplying y minus bx. Alright. So we are going to get the result of these 2 divided this, we are getting 1. So we have by minus x divided by y minus bx, right? So this is the value of dy dx, right? Now we have to find the value of dy dx at a given point. So at a point with x coordinate of 0 and y coordinate of 1. So we need to substitute the x and the y component into the derivative, that's dy dx. So we have b here, the value of y is 1, so minus x, which is 0, alright, divided by y, and our y is 1, minus bx, so our b is here, our s is 0 over here, alright. Okay, so here we are going to get just b minus 0 divided by 1 minus what? 0, right? So at the end, you are going to get b divided by 1, and the answer will be equal to b, alright? So we conclude, therefore, dy dx is equal to b at a point with x coordinate of 0 and y coordinate of what? 1, alright? So thank you for watching. Please do not forget to subscribe to my YouTube channel, which is Math with Ebefa, and also share with others to like and comment on my videos. Bye for now.